Hi! On your screen, you see the review of the details that you need to remember when we talk about writing isotopic, or sometimes they call that atomic symbol. Now on your screen, let's have a review again. Atomic number is Z, and the Z can be found in the periodic table, and that number is equivalent to the number of protons. Next is the mass number, which is symbolized by A, and A is always equal to the total of the number of protons and the number of neutrons. And so from that formula, you can already derive the number of neutrons, which is the mass number minus the atomic number. And or you can get the number of neutrons by subtracting mass number minus the number of protons, because the number of protons is always equal to the atomic number. And always, it's correct to assume that in a neutral atom, the number of positive protons is always equal to our number of electrons. So here in this video, I'm going to show you another example of filling out a table with different isotopes and at the same time writing its atomic symbol. So let's proceed. On your screen, you see copper 63, the first one. Then we have nitrogen and then iron Fe. The first one is copper 63. The given is just copper 63. And we know that the 63 after the dash represents your mass number. In the second given, nitrogen, you don't have a number after it, but you're given the number of neutrons. While in the third one, which is the same with nitrogen, Fe, iron, you're not given any number after the symbol, but you're just given the number of neutrons. So let's approach each of these given one by one. So the first one, you see copper 63. So this will be easy for us to determine what are the number of subatomic particles and its atomic and mass number, because 63 is already given. So 63 automatically is the mass number, which falls in the column of A. And because copper, when you look at the periodic table, copper has an atomic number of 29, that means the Z value is 29. So it's important that you need to look at the periodic table so that you would know what's the atomic number of the element. And because the atomic number is equal to the number of protons, so the protons is also 29. And because protons is equal to electrons in a neutral atom, so electrons is also 29. To get the number of neutrons, it's A minus Z. So 63 minus 29 is equal to 34. So the number of neutrons is 34. To write the atomic symbol of copper, it's gonna be written this way. Cu, the symbol of copper, and then on top is the mass number 63, and the subscript will be 29, which is the atomic number. Now let's go to the second example, nitrogen. Nitrogen has a given of 7. Take note, it has a given of 7, and it's just nitrogen here in the given. So first thing that you need to do is go look at the periodic table and see what's the atomic number of nitrogen. So when you check the periodic table, the atomic number of nitrogen is, the atomic number of nitrogen is 7. So 7 is what you will place here. And because atomic number is equal to protons, which is also equal to electrons, so all of them are 7. And because to get the mass number, it's the atomic number or protons plus neutrons. So 7 plus 7 gives you 14. So that's how we got the mass number of 14. That's why your number of neutrons is given, because you need to add it to its atomic number for you to determine the mass number. And so to write the atomic symbol of nitrogen, it's going to be 14 on top, the mass number, and of course 7 being the atomic number below. Okay, let's now go to the third example, iron. This has the same approach as nitrogen because you're given the number of neutrons for iron. And so the first step, if you're given like this, is you look at the periodic table, check where iron is, and look for its atomic number, and you should find that it's 26. So atomic number 26, which is equal to protons and also electrons. So you get 26, 26, and 26. Then add the 26 to the number of neutrons. So 26 plus 29, you will get 55. And now you're ready to write the atomic symbol of iron, which is 55 on top and then 26 below. So the complete answers to this particular problem are all on your screen. Please refer to this, and I hope that you're taking notes while I was discussing this particular example. So if you have any questions, please leave in the comments below. I will be very glad to assist you in your learning, and I hope that you learned from this video. Please don't forget to like, share, and subscribe to my YouTube channel, Narcademy. Bye-bye till next time. This has been Madam Narca saying don't stop learning, relearning, and unlearning. Bye-bye.